All right, so today's lesson is going to focus on lesson 12.8, surface area of prisms. In the previous lessons, we've talked about area, we've talked about circumference and perimeter, and then previously we've talked about volume of three-dimensional shapes as well. This lesson is going to talk about one of our last measurement types of topics, which is surface area. Now it says surface area of prisms, but I also threw in some cylinders as well, since you might as well see that formula at the same time. So let's talk a little bit about what surface area is. Surface area specifically measures the total area of all of the faces of a three-dimensional figure. So if I'm going to wrap a package or a present, we're talking about the amount of surface area that we need to cover. If I'm going to recover, let's say, a couch or some sort of piece of furniture, and I need to figure out how much fabric I need, we're talking about surface area. If we need to replace the lining in a pool, we're talking about surface area. Even if I'm going to paint a room, we're talking about surface area because we're talking about painting all of the surfaces, maybe not the floor, maybe not even the ceiling, but you're finding the area of all of those walls, adding it together to figure out the total surface area that you're going to paint. So I want to begin by talking about how to find the surface area of a rectangular prism. Back in elementary school, you probably had to cut out something that looks a lot like this, and then we're asked to put it together to form a three-dimensional shape. This is what we call the net of a three-dimensional shape. It's taking a three-dimensional shape and laying it flat. The reason why this is important is it kind of tells us where our formula for the surface area of a rectangular prism comes from. So our formula is 2LW plus 2LH plus 2WH. The 2LW comes from these two faces that happen to be the same size. We have two of them, and their areas are length times width. The 2LH comes from the area of these two surfaces. Since the dimensions of these are L and H, we find the area by taking L times H, and there's two of them. And then finally, 2WH comes from the area of these two surfaces, which have dimensions W and H. And again, there's two of them, so we take 2 times W times H. For surface area, you'll sometimes see S used instead of SA. Sometimes you'll see SA used for surface area. It's not a super complicated formula. You can even just find the area of all the surfaces and add them together separately. It does take some time to work through though. So you may want to pause the video at this point and stop and think how you might find the surface area of a cube. So a cube has 6 faces, and every face is the same size. They're all squares. The area of each squared is s times s, or s to the second power. Since we have 6 of them, if I want to find the surface area of a cube, we want to do 6s squared, or 6 times s squared. This is a whole lot easier than doing this up here, although it doesn't matter whether you use this formula for a rectangular prism or this formula for a cube, you'll get the same solution. When we talked about volume and when we talked about area, squares versus rectangles weren't that different, but this is a little bit shorter than this guy up here. So let's do some practice of finding the surface area of some rectangular prisms. So the first thing that I usually do is identify which dimension I want to be my length, which one I want to be my width, and which one I want to be my height. It doesn't actually matter. This is what I chose, the length to be 5.8, the width to be 2.1, and the height to be 2.8. If you choose them differently when you go to do your work down below, these products are just going to be in a different order, but you still get the same final solution. The reason I like to identify them is since we're not just taking length times width times height like we did for volume, it's easier to keep track of which numbers I'm using where in the formula. You're going to notice I plug these in, so if at any point you need to pause the video and fill in the blanks, feel free to do that. You're going to notice that I used parentheses for multiplication instead of the dot. And the reason why I did that was so that our decimal point didn't get confused with a multiplication sign. You don't have to do it. It just helps to not get those confused. So we'll take 2 times 5.8 times 2.1 to get a product of 24.36. Take 2 times 5.8 times 2.8 to get a product of 32.48. And take 2 times 2.1 times 2.8 to get a product of 11.76. Add those three products together, you get a total surface area of 68.6 feet squared. Note the squared label instead of cubed because we're talking about an area. That's really important. Volume is cubed because we're filling in that space. But since we're talking about area here, even though it's surface area with three-dimensional shape, we're going to use feet squared, inches squared, meters squared, etc. At this point, you might want to pause the video and take a look at number 2 on your own. In a moment, we'll look through the work. All right, so for number 2, I identified your length is 22, width is 13, and height is 14. Again, it doesn't matter which one is which. When I go to do my work, I'll have 2 times 22 times 13, which is 572, 2 times 22 times 14, which is 616, and 2 times 13 times 14, which is 364. Add those products together to get a total surface area of 1,552 inches squared. Now, if you're given something that's not a rectangular prism, but it is still a prism, you're going to use the surface area formula for a polygonal prism. If you did polygonal prisms last year, the surface area, you might have had a different formula. For whatever reason, when I taught sixth grade students in years past, the sixth grade formula sheet has a different formula for the surface area of a polygonal prism. I also used to teach finding the surface area of triangular prisms and other prisms differently, which would be find the area of all of the faces and add them together. That work would usually take up at least half of a page. This formula, the formula sheet for seventh grade, added this several years ago, and I actually really like it. So this is probably my favorite formula to use for the surface area of a polygonal prism, although there are other formulas or other methods floating out there. So the formula is capital P times W plus 2 times capital B. P represents the perimeter of the base. That's new for us. And we'll do some examples of finding the perimeter of the base in a moment. W represents the width of the prism, which is still the distance between your two parallel faces. And then capital B still represents the area of the base. That hasn't changed. So I typed in an example to the guided notes to help you see how this works. Then we have 3 practice problems to do. It may not be a bad idea to pause the video and try some of these on your own whenever you feel comfortable. So we've got a triangular prism here. The formula is PW plus 2 times capital B. The first thing I'm going to do is find the perimeter of the base. And remember, since it's a triangular prism, our bases are triangles. So I'll highlight those, even though it's sitting on a rectangle. The dimensions of the triangular bases will be 15, 15, and then 18. It's not always going to be labeled on both triangles. So add 18, 15, and 15 together to get a perimeter of 48 meters. For the area of the base, since it's a triangle, we're going to do half times base times height. The base and height intersect at a 90-degree angle, which we have right here. So we do half times 18 times 12 to get an area of the base, of 108 meters squared. So in our formula, we've got perimeter of the base, which was 48, the width of the prism, which is the distance between your two triangular bases, which will be 22, plus 2 times area of the base, which is 108 from over here. That's going to get us 1,056 plus 216, a total surface area of 1,272 meters squared. All right, so let's take a look at number 3. I believe it might be number 5 on your guided notes. It's because I moved some things around. So just look for this figure in your guided notes. First things first, let's find the perimeter of the base. That's going to be your 2 triangles. The dimensions of your bases will be 4, 4, and 4. It's an equilateral triangle. 4 plus 4 plus 4 gets us a perimeter of the base of 12. Now let's find the area of the base. Remember, it's half times base times height. Base and height intersect at a 90-degree angle, so those will be 4 and 3.5. Do half times 4 times 3.5 to get an area of the base of 7 meters squared. All right, let's plug these into our formula. Becomes pretty redundant after a while. You see a lot of the same work. So perimeter of the base we found to be 12. Width of this prism is going to be the distance between your two triangles, which is 4, plus 2 times area of the base. Area of the base is, whoops, sorry, wrong color here. Not that it matters, does to me. Let me highlight those in blue. Bear with me just for a moment. This guy right here. Plus 2 times area of the base. Area of the base will be 7. 12 times 4 is going to get us 48. 2 times 7 is 14. Add those together to get a total surface area of 62 meters squared. All right, number 4. Let's begin by finding the perimeter of the base. Your bases, again, are triangles, so we'll highlight those in yellow. This guy here and this guy here. Our dimensions are 10, 11, and 14.9. Add those together to get a perimeter of the base of 35.9 feet. Now let's find the area of the base. Ooh, let's find the area of the base. We'll fix that there. We're going to take half times base times height. The base and height intersect at a 90-degree angle, so that'll be 10 and 11. Half times 10 times 11 gets you an area of the base of 55 feet squared. Yikes. Sorry about that. It's just one of those days. All right, let's go ahead and find the surface area of this triangular prism. Computer would cooperate with me, that would be nice. There we go. So we've got P times W, perimeter of the base we found to be 35.9. Your width of your prism, make sure to highlight this in the right color here, is 20, distance between your two triangles. Plus 2 times area of the base. The area of the base we determined was 55 from over here. 35.9 times 20 is 718. 2 times 55 is 110. Add those together to get a total surface area of 828 feet squared. All right, again, you might want to pause the video to take a look at this problem on your own. It's number 7 in your guided notes. I did correct the numbers here so they match your guided notes, although I think they should actually be numbered differently than this, but we'll go with it. All right, let's start by finding the perimeter of the base. So our bases are the two triangles. Our dimensions are going to be 10, 10, and 12. I'll highlight my bases here. So we've got 10, 10, and then 12. 10 plus 12 plus 10 in any order is 32 meters. Area of the base is going to be half times base times height. The base and height intersect at a 90-degree angle. So those will be 12 and 8. Half times 12 times 8 gives us an area of the base of 48 meters squared. Let's plug these into our formula. So we've got perimeter of the base, which was 32, times the width of this prism, which will be 15, distance between your two triangles, plus 2 times area of the base, which is 48. So we're going to get 480 plus 96, total surface area of 576 meters squared. All right, so we've got that octagonal prism again. Luckily, this work is a little simpler than when we took a look at the triangular prisms. So our formula is capital P times W, and the perimeter of the base is given to us. It happens to be 32. Oh, times the width. The width of this prism is going to be the distance between your two octagons. That will be 2.8. Go ahead and highlight that. Plus 2 times area of the base. The area of the base is also given to us as 45. 32 times 2.8 is 89.6. 2 times 45 is 90. Add them together to get a total surface area of 179.6 meters squared. All right, let's also take a look at this pentagonal prism as well. So for our pentagonal prism, the perimeter of the base is given to us. It is 25. The width is the distance between your two pentagons. That will be 6. Plus 2 times area of the base. Area of the base is also given to us as 125. 25 times 6 is 150. 2 times 125 is 250. Add them together to get a surface area of 400 centimeters squared. So again, I also added in surface area of cylinders. So the formula is 2 pi r squared plus 2 pi r h. And again, you sometimes see SA for surface area, sometimes S. Doesn't really matter. If we want to create the net of this cylinder, it's going to form two circles. So where the 2 pi r squared comes from in this formula is from your two circles, which are part of your cylinder. The 2 pi r(h) is a little bit more complicated. It comes from the rectangle. So the area of a rectangle is length times width. And if I take this curved surface and lay it flat, it's going to form that rectangle. The length is actually going to be the circumference of your circular bases, and that's 2 pi r for the circumference of a circle. The width is going to be the height of this, so that's where the 2 pi r(h) comes from. You don't really have to have a full understanding of that, but there is a place where this formula came from. It wasn't like someone just made up the formula randomly and said, hey, I think it sounds good to have 2 pi r squared plus 2 pi r(h). It does come from flattening this thing out, finding the area of the two circles, finding the area of the rectangle, and adding those together. So let's do some practice. Numbers 10 and 11 are actually very close in answer. Number 10, you're just filling in some blanks. Recognize the radius to be 4.6, your height to be 6. So we've got 2 times pi times 4.6 squared plus 2 times pi times 4.6 times 6. The way I plug this into my calculator is I do 2 times pi times 4.6 squared. I hit equals, and then I do plus, and then in parentheses, 2 times pi times 4.6 times 6. You don't actually need the parentheses there, but I usually do include it. I don't like to plug it all in one big step, although you really can. You're going to notice I didn't put any in between steps because that would involve rounding each of these, and I don't like to do that. So this is one of those times where you're kind of plugging it all in at once. The reason why I like to pause after this first part is if we were doing it in class, it would give you a chance to check and see, did I plug in that first part correctly? But when you plug it in, you may want to practice plugging it in. You should get about 306.4 meters squared. All right, let's take a look at our second cylinder. Again, you may want to pause the video, try it on your own. Just make sure you're using the radius of the circle, which is 4.5, not 9. All right, so since the radius is 4.5, we'll do 2 times pi times 4.5 squared plus 2 times pi times 4.5 times the same height of 6. They won't always have a height of 6. That's going to get us approximately 296.9 millimeters squared. All right, I do also want to take a look at number 12. So most questions are going to have answers that are reasonable and make sense. This one is definitely way too high for the problem. So I made a note to change this last year, and I don't think I did in my guided notes, but this will remind me again, make sure you change it in your guided notes. So number 12 says, Mara is going to wrap a box in the shape of a rectangular prism with dimensions 15 inches, 18 inches, and 3 inches. First things first, find the surface area of the box. It's a rectangular prism, so we'll plug in 15 for L, 18 for W, and 3 for H. So you've got 2 times 15 times 18, which is 540, 2 times 15 times 3, which is 90, and 2 times 18 times 3, which is 108. Add those together to get a total surface area of 738 inches squared. Now, part B is the part that is a little new. It says the wrapping paper costs 45 cents per square inch, which is ridiculously high. What will be the cost to wrap the box? Well, if I know the total surface area of the box or rectangular prism, I know the cost per square inch, just multiply them. We saw this back when we did area problems as well. So we'll want to take 738 times 0.45. Make sure you do that instead of 45 since it's 45 cents. You'll get a total cost of $332.10. Again, I usually ask you to stop and think, does my answer make sense? Is it reasonable? Not so much here. It doesn't happen very often. I'm going to change this to a much lower cost per square inch instead of it being 45 cents per square inch. But either way, you're going to follow that same strategy, same method, even if it would be 2 cents per square inch, for example. All right, so from here, I'm going to give you some independent practice to try on this. Next week, we've got our soft rollout of setting up our assignments for each different class that you need to complete 4 grades. We'll talk more about that as we get into next week. Hopefully, we'll have everything organized and ready to go for you. It is a learning experience for all of us, but we'll get through this together.